In all of these processes, like we said before, there are some parameters that varies or changes with condition of these processes. And these parameters, as they change, they have the capacity to affect the process and thus the outcome. And once the outcome of the process is affected, what it means is that the desired output from the process may not be achieved, or will not be achieved. Okay, so these parameters that varies with process conditions that can affect the process, they are called process variables. Okay, so we need to appreciate them, how to monitor them, and how to control them, and what instrument we need to use to monitor and control these process variables. So as you can see, we have pressure. Pressure is a process variable or process parameters that can change oftentimes with changing process condition, as we'll see later. We have temperature, we have level, okay, we have flow, we have position, okay, then we also have force, we have density, viscosity, sound, we have even the pH, okay, of the process. All of these, they can change with changing process conditions, and they can affect our process or the output from our process. Okay, so we will look at them in a little bit details later, especially the most common process variables, the pressure, temperature, level, and flow. So it actually depends on the process that you are looking at. Okay, some of these parameters in a certain process could be more important than some other parameters, okay, or variables. So in some processes, maybe it is only one variable, maybe temperature or pressure, that has the capability of affecting our process, and thus that is the only variable we'll monitor. Okay, while in some, maybe it is the pH, so which means that it is the pH of the process material, okay, or process fluid of our process that we need to look at, because as the pH is changing, it can affect our process, affect the outcome of our process. Some is the viscosity. So, but for the sake of this program, we are going to look at the most common process variables, which are the pressure, force per unit area, temperature, the degree of hotness or coldness, the level of fluid in a vessel, then the flow, okay, the flow rate, volume per unit time that goes through a specific section of the process. So those are the ones we are going to be looking at in this program. But all of them, as we'll see later, we have instruments that are used to look at them. They are called sensors. Okay, we have sensors for pressure, temperature, level, flow, position, force, density, viscosity, sound, and the pH. Okay, so we have the sensors. Then we also have the instruments that will help us to magnify the output from these sensors, okay, and then that can also compare it to a set point, okay. So those are called the controller, and then maybe that can send it to wherever we want that information to go, okay. That's where the transmitters will see later. So we have all of those, and then if there are adjustments that need to be made to the process, the information could be sent to the final control element. What those final control elements are, we'll see them later, so that the necessary appropriate adjustment could be done to return that process variable back to what we feel is normal. Okay, so here we have a very simple, we have a process, okay, that is represented diagrammatically on the left and on the right. So we have different variables that we need to be looking at. Okay, there are, like we said earlier, there are some variables that are more important to a particular process than others. So that variable that have that strong effect on the process, they are the variables that we monitor. So let's take, for example, this process on the left. Okay, so where fluid is continuously fed into this flash drum. So definitely, as the fluid is fed into this flash drum, the fluid is coming at a particular pressure. So in the drum, it is subjected to a lower pressure. So which means that some of the volatile components in the fluid will be flashed out. Okay, they will go into the vapor state, and those vapor will rise up, while those that did not flash out, okay, those that are still liquid, will remain in the liquid form and settle at the base of this drum. So it is a kind of separation process where you separate the lighter component of the mixture from the heavier component of the mixture. Okay, so the rate at which the feed comes into this drum will determine the level, are we getting it, of the part of the fluid that remains in liquid in the vessel or in the drum, and also determine the amount too that is flashed out that will form gaseous vapor, okay, in the upper part of the vessel. Definitely, if this level rises above a level, you see that it can affect the balance in the drum. Okay, assuming it goes beyond this level. Of course, the rate at which it will be flashing or coming into the drum to flash will adversely be affected also. Okay, so we do not want it to get to that level. So what do? We need to monitor this flow rate and control it. Are we getting it? So here on this leg, we see that the flow of our feed or of the process fluid is more important for us here. Okay, so we monitor the flow. Here we have the sensor that goes to a flow controller that controls the final control element that helps to adjust the flow rate into the drum. Then the fluid that is settled down in the drum, we do not want it to go beyond a certain level. Okay, so you see that the process parameter level becomes a very important variable, because you know, as the drum is filling, the level is changing, it will be increasing. As you are drawing out, the level is also going down. Okay, so here we need the level sensor that senses the level, send the signal to the controller that adjusts the final control element, such that when it gets to the required level, this valve will open up, and then we will remove some of the fluid from the bottom of the vessel out of the vessel. Then remember too that some of the lighter end of the feed that are flashed out will definitely tend to increase the pressure of the vessel, okay, above the liquid. So as that is happening, the pressure here is increasing. When the pressure increases to a level, okay, we need to relieve the vessel of that pressure. So a very important parameter for us to get those vapor out is the pressure. So when you look at the pressure, there is a sensor here that sends signals to the controller to the final control element. So when the pressure rises to a level, it opens up and then the vapor is taken out of the vessel, so as to maintain a balance that will allow our flow rate to be maximized or optimized, such that we'll have the maximum flashing out of the liquid that is sent into the vessel. Then when you look at the right, here we have a steam generation system. Okay, so in a steam generation system, you know, the boiler is a very important piece of equipment, as you can see. Okay, so in the boiler, what happens is that the chemical energy that is contained in fuel is converted to heat energy, and that heat energy is absorbed by water, and then the water is converted to steam. Are we getting it? So in the mud drum and the steam drum, we need to maintain a particular level of water. Okay, so when you look at it, we have a level transmitter. This level transmitter sends signal to the level controller, and then the level controller sends signal to the IP converter, and then to the final control element, which is the valve that feeds water into the boiler. Okay, so as more steam is generated, this water comes down, this level sensor senses it, sends signal to the valve opens up and add water to the boiler. Okay, the boiler drums. So that is the level at that stage. Then now we also have other, if the energy that is contained, the steam pressure is not high enough. Okay, we need to increase the steam pressure. You see that there is a pressure sensor here, pressure transmitter, pressure controller, that sends signal to the fuel valve. As you can see, it's on the fuel line. Okay, sends signal to the fuel valve to increase the amount of fuel that is sent to the burner, to increase the amount of heat that is generated here, and then the amount of heat that is absorbed, the amount of steam that is generated will also increase, and thus the pressure of the steam will be increased. So you see that at different points, different process parameters, they are important to us. So we need to monitor them, control them, so as to get the desired result from the processes. Okay,